Okay, so in the last segment, we have actually reviewed our hands-on in the GIS practical. And at least what you have done in this practical is actually something that you will be doing when you're making maps, when you're um, integrating different spatial data, making sure that they are, in the same reference frame and etc. And the other thing is actually um, at least you can do it in one single software. And I would think that whenever you want to do it in other GIS software, for example, or other visualization software, you've got the basics of how you're actually doing it, and you've got the basics of why you're doing everything, because I think each software has their own kind of manual. You will be able to, to grasp what the manual means and how to do it if you already have a hand in at this one software, because I think there's a lot of software in this world, and you cannot really make like a standard of which software is better than another, because it really depends on where you're working and to whom you're working on. So that's basically what I tried to deliver to you in the previous segments. And now we're going to talk about the product standards, because there are actually different standards whenever you're working for a company, or are you working with, a hydrographic office or any other offices. And the standards that I'm going to present to you are the standards that comes from IHO. So the first one is you've got a new standard that is called S100, which is the Universal Hydrographic Data Model. So if the S44 standard is basically for, it's a standard to make sure that your data is appropriate, that your data, you will have a data, it has to, it S44 is basically a guide to plan your survey lines, for example, and then to check if your data has complied with the standards, the order 1B, order 1A, etc. And then that's basically S44. But S100, it's basically a framework document that is intended for the development of digital products and services for hydrographic, maritime, and GIS community. So basically, IHO and other international organization is trying to make bathymetry data, or basically any hydrographic data, as accessible as possible to other users. So for example, in here, this is the S100 world, that's how they call it. So actually S100, you've got a lot of branches. So for example, you've got in here your ENC, okay, your electronic navigation chart, nautical chart, sorry, electronic nautical chart. And then you've got your S102, that's your bathymetric surface. And then I will see if we've got 103 in here. No, but okay, you've got S101 again in here. That's electronic navigational chart. You've got S104 for water level information and surface navigation. You've got S111 for surface currents, etc. So a lot of things that are standardized in here. So why are they standardized? It's basically to make sure that every information can be read by any people that's reading it. Okay, so again, it comprises multiple parts that are based on geospatial standard, and it's developed by the International Organization of Standardization for the Technical Committee of 211. So this is the standard that we will be focusing on today. So the S102, that's basically a standard for bathymetric surface product specification. So you can have a look at the document. I think you can download it for free in IHO website. So the S102 is basically, it's developed by the ONSWG work on the bathymetric attributed grid, or the BAG. And it will be used as a bathymetric coverage layer for navigation and maybe other purposes. So the idea of S102 is basically you need to have an input assessment and preparation. You review all the project resources, and then if you want, you can make auxiliary vector layers. For example, if you want to say that, okay, this one is a hazard, maybe that's a shipwreck, or maybe there are some buoys placed in there, stuff like that. So you can make a vector layer out of that, okay? And then you can cut all sources into tiles. So if you want, you can actually separate your data into tiles if you still want to preserve the the quality of the data without actually ruining your space, because maybe it's harder to load a huge data set. It's better to have small data set, but they're in chunks, and then you have a big data set, although it's not in one. And then you want to have the XYZ point data processing. You want to build your surface model, as we have done in practical H6. And then you want to have a high water break line. For example, if you want to cut your zero, because normally we already assign where our zero is, but if we want to make it different, then we can just calculate again. And we can actually say, if you want to make, for example, if your bathymetry is in here and your zero is in here, if you want to make it lower, then you can actually just make the bathymetry lower as well. But if you want to make your zero higher, for example, then you can just operate your bathymetry and make it higher. That's the basic idea. And then you can interpolate initial product surveys, as we have done in the practical. And then there's an additional surface data integration. If you've got any other sources of data, you can integrate it. That's what we did in this practical already. And apply conflict resolution rules in overlap areas. So basically, if you've got area with that is overlapping and they've got different resolution, you know how to do the integration already. Actually, it's because you can interpolate them into two different surfaces, but make sure that they are in the same cell cell size, and then you can integrate them just like that. And then the final one is going to be product creation. You can extract the final product surface. That's what we did already. We can when we extrapolate it, we save it into a new grid file. That's what we did in H6. And then you can export you can export the file. The one that we exported was in GRD, but you can export it into GeoTIFF or other files, or the other type of files that is needed by the company or by the people that requires it. So basically, this workflow, this whole workflow, we have done it in our practical. Okay, and then now the data integration. So we have already done this as well, but maybe not as many data as we can see. But this is just, an illustration of what kind of data that you can actually integrate into your GIS. So you've got your seabed features. We have done that. We've got your bathymetry. We've done that. You will have your side scan mosaics if you've got side scan sonar surveys. And then you will have sediment data, for example. Maybe you have the data from geologists, or maybe you have the data from borings, or maybe sediment sampling. You will have geotechnical samples. You have to make sure that where the borings are. And then you will have multi-beam backscatter mosaics, and then shallow geohazards maybe. And then you've got your navigational chart. Maybe if you want to add it, you can see like maybe where your survey line tracks is. You can import it in there as well. And you've got TS slips. That's basically another type of geotechnical or geophysical data. So the seabed survey data model is basically like a GIS template for seabed survey industry. It provides core components typically used in oil and gas companies, but you can use it for any other purposes. And we have already done it in our practical. And then you can actually visualize the data. We have done this in the practical as well, but if you want to try, you can actually visualize your data in the H7 practical into a surface by using the QGIS to 3GIS plugin. And then you can visualize all the data that you've got. And this one is, as you can see, this one is geophysical data, because not only that you've got the data in the surface, but you actually have the data that is below the surface. So you can see some borings in here. You can see some, some other, three-dimensional surface below it. So the idea of having the data visualized in here is to actually make, several layers of data, and you can actually visualize it. So through SSDM, we expect to have a complete survey data management workflow. So you know what to do one by one, like what you do first, and then afterwards what you're going to do. And we're going to talk about the workflow after this. And then you will have an improved geohazard catalog and interpretation knowledge base. So basically, you want to transfer your knowledge into another user, okay? So SSDM will actually make it easier for the user to read what you have done and what you have actually interpreted from the data. And then you will improve the integration of the geoscience software, because again, there are a lot of geoscience software in this world, but you need to understand the very basic of what you're actually doing. And then finally, that's the data exchange. And then the accessibility as well. So people will be able to access what you have done if you make a really good database out of it, okay? So this is basically the workflow. You can start anywhere, but basically it's kind of a circle. So for example, if you start at the survey planning, then you will do field data acquisition, and then you will do processing and interpretation if you need. And then you will make your reporting charts and maps. That's basically your final product. But you will also make the database as well, your GIS database. And then from this, even from the reports, from your database, you will know, okay, what else should I do with this area? Then you will go to your survey planning, and then you can go back to field acquisition and etc. So the workflow isn't actually from one place to another. It's not like a pyramid, or it's not even like a line, but it's actually a circle. Okay, it's actually like a cycle of a workflow. So I think that's it for today's lecture. It's quite short actually, and it's quite sensible to do it. And for the last practical, I think I will try to give you some, some types of data interpretation techniques, and maybe some 3D surface visualization. So see you in the practical.